This video is on oxidation states. And our aims for this video is to be able to calculate oxidation states of elements in a compound and to identify oxidizing agents and reducing agents in a redox reaction. So before we start calculating oxidation states, we need to understand what they are. Oxidation states are the theoretical charge on an atom in a compound. And the reason why these are important is because you can work out the theoretical charge of an atom in a covalent compound as well as in ionic compounds. And if we can work out the oxidation states, we can work out whether they've been reduced or oxidized in a reaction. To do this, we can follow a number of different rules. The first rule is that all the oxidation states of the atoms should add up to the charge on the molecule, or the compound, sorry, or the ion. So that means that if you are trying to work out the oxidation state of an atom in a charged ion, for example SO4 2- or OH-, then it needs to add up to -2 and -1 respectively. So that's our first rule. If it's just a neutral compound like water or sulfuric acid, then it needs to add up to 0. Our second rule is that H always has an oxidation state of +1. The only exception to that is hydrides. So for example, lithium hydride, there the hydrogen would have an oxidation state of -1, but in all other compounds, +1. The third rule is that oxygen is always has an oxidation state of -2. Again, there's an exception, and that exception is hydrogen peroxide, where oxygen has an oxidation state there of -1. The fourth rule is that group 1 and 2 elements have oxidation states of +1 and +2 respectively. What I mean by that word respectively is that group 1 elements have an oxidation state of +1 and group 2 elements have an oxidation state of +3 and +2, sorry. And our fifth rule is that aluminium is +3. It's in group 3, but we can't say that all group 3 elements are always +3 because they're not. So if we try and use these rules for a molecule, so for example we might want to work out, let's start with sulfuric acid, and we want to work out the oxidation state of sulfur. First step here, all the oxidation states should add up to the charge on the compound. So the charge, excuse me, the charge on this compound is 0. So all the oxidation states should add up to 0. The next step is to think about what H2 and O4 add to the oxidation state. So each H would have an oxidation state of +1, so 2 of them would have an oxidation state of +2. That's not to say that the hydrogens have an oxidation state of +2, that's them combined. If you're asked for the oxidation state of just one hydrogen, you'd say it was +1. Similarly, the oxidation states of the oxygens have a total oxidation state of -8, but again, each individual oxygen has an oxidation state of -2. That means our sulfur must have an oxidation state that when you add 2 to it and take 8 away from it, it adds up to 0. So our sum could be something +2 take away 8 equals 0, and that something is going to be +6. So oxidation state of sulfur there is +6. Our next example is NO3-. So here we've got a charge, and so our oxidation state should add up to -1. The oxidation state of 3 oxygens will be -6 because each one is -2, and so we're thinking about something -6 equaling -1, and that something is going to be +5. So our oxidation state of our nitrogen here is going to be plus 5, because plus 5 minus 6 was minus 1, which is our overall charge on that ion. The final thing I should say is that any element by itself, so say aluminium by itself, or oxygen as a compound like O2, any element has an oxidation state of 0 by definition, because, well, the charge on them is 0, and so each one must have an oxidation state of 0 in order for their oxidation states to add up to 0. Similarly, if one of these had a charge, so for example aluminium 3+, the oxidation state of that ion will just be the charge on the ion, because there's only one thing in the compound, if you like. So our next aim is to look at how to work out what an oxidizing agent and the reducing agent is for a redox reaction. To do that, I want to show you a redox reaction. So you're going to see a video now of the Thermit reaction. Okay, so the Thermit reaction is iron oxide reacting with aluminium to make aluminium oxide plus iron. And to work out what the oxidizing agents and the reducing agents are in this reaction, we've got to work out the oxidation states of each thing. So first, if we just sort out the aluminium and the iron by themselves, we saw in the last slide that elements by themselves have an oxidation state of 0. So both the aluminium and the iron have an oxidation state of 0. All of the oxygens have oxidation states of -2, because that's a rule. We know the oxygen has an oxidation state of -2. The iron here will have an oxidation state based on the fact there are 3 oxygens attached to it and the overall charge is 0. Now 3 oxygens will have an overall oxidation state of -6. That means each of these ions, because there's 2 of them in the compound, must have an oxidation state of +3, and that's going to be the same for this aluminium on this side, because it's essentially the same structure, it's just the different element. So we can see that the oxidation state of the oxygen has not changed, but the oxidation state of the iron has gone down, and the oxidation state of the aluminium has gone up. That means the iron has been reduced. So the iron has been reduced, and therefore it's gained electrons, and aluminium has been oxidized, and therefore has lost electrons. Now, in becoming oxidized, the aluminium has also facilitated the reduction of the iron. And so we call the aluminium the reducing agent. So whatever gets oxidized is the reducing agent, because in being oxidized, it has reduced the other thing. The iron, therefore, is our oxidizing agent, because in becoming reduced, it has oxidized the other thing. Oxidizing agent. Sorry, I spelled that wrong to begin with. Oxidizing agent. So basically what's happened here is the aluminium has become oxidized and lost electrons, and it's lost electrons to the iron. The iron has gained those electrons the aluminium has lost. So they are benefiting each other, if you like. The aluminium is being oxidized and therefore is reducing the thing, so we call it the reducing agent, and the iron is being reduced and therefore it's oxidizing the other thing, and so we call it the oxidizing agent. So just thought I'd finish with an exam question that has been asked on this. So sulfuric acid is made from SO3, which can be manufactured in a series of stages from iron 2 disulfide, FeS2, found in the mineral iron pyrites. Deduce the oxidation state of sulfur in each of the following compounds. So SO2 is going to be easy. We've got 2 oxygens, and each of those have an oxidation state of -2, so overall that's -4. We have to, it has to add up to 0, and therefore our oxidation state here of sulfur must be +4 to balance out the -4 from the 2 oxygens. This second one here is slightly less obvious, and I've got to just show you another thing that you need to know to work out oxidation states, and that is to look at the compound up here, the name of it. Now this 2 here, there's a Roman numeral 2, represents the oxidation state of the thing before it. So iron 2 disulfide means that this iron has an oxidation state of 2+. And so that means each of these sulfurs need to balance out, or the sum of these 2 sulfurs' oxidation states must balance out that 2+ oxidation state from the iron. And so the sulfur here in FeS2 must be -1, as the charge on FeS2 is 0, and so they have to add up to 0. I hope that helps. Please email me if you need any more help on any of this.